All right, so let's get started. So hello everyone, I'm Beej, one of the organizers. Today we're going to cover Intro to Docker. This is being recorded. I'm going to share the presentation and the recording afterwards, so if things are a little fast, you can always catch up later. But we'll do our best now. Real quick thing about managing expectations. We're going to go very fast, okay? We're covering a lot in just 30 minutes, so I will not stop and ask for questions, even though I normally do. Also, it's going to be less entertainment. Usually I try to keep things fun and have all sorts of fun memes and all that. We're not going to have a lot of that. There's also going to be minimal theory. I'm not going to explain a lot about how Docker exactly works or why it was made or the history, none of that. There's not going to be an interactive portion. Normally when we do workshops, we have a thing where we work on stuff together. There's a goal, there are steps. But in this case, I'm just going to demonstrate. Also, I'm only going to cover the likely usage, not all the different ways you can use it, just the most likely way that you will use it for your project. And lastly, I mentioned that we are recording this. We will post it. You can use it as a reference. Okay? So here we go. So today, we're going to cover why would we use Docker and why would we use Docker Compose, so you can determine if it's useful for your project. Hint, hint, it probably is. We're going to go a brief bit about how Docker works, okay? Because you need to understand at least a little bit in order to use it properly. Then we're going to go ahead and create a Docker image, a very basic one from scratch. And then we'll set up a nice little development environment using Docker Compose, where we can set up our application and a database and an interface to the database without writing a huge amount of code or installing all sorts of crazy software. Now, one quick thing. We just assume that you have Docker installed already. So before you try to do this stuff, you probably want to install Docker Desktop, okay? Again, you don't need to follow along right here, right now, and I'm probably going to go too fast for you to follow. But make sure you install Docker when you do try to do this stuff. Otherwise, you're going to be like, why doesn't it work? All right, so here we go. So why use Docker? The big main reason is a consistent environment, right? So if I run it on my computer and you run it on your computer and Billy Joe Bob runs it on his computer, we all get the same thing, okay? Another thing is easier configuration. If it's all configured inside the container, you don't have to add any additional configuration. It's also a shareable environment. When we create this consistent environment, it is easy for us to share this environment with each other, either through the Docker files themselves or pushing and pulling images. And it's also easier to deploy once you get to the point of deployment. Tomorrow we will do a workshop on deploying using Vercel, which does, I think, support... No, never mind. Forget I said that. We will do a workshop on Vercel. It has nothing to do with this. Sorry, I was confused. So that's why you would want to use Docker, basically ease of environment, ease of sharing. And then why use Docker Compose? Docker Compose allows you to pre-configure multiple containers. So if you rely on numerous services to run your application, you can just pre-configure them, put it in source control, and then everyone on your team can have the same environment even if it's multiple services. Additionally, these containers can automatically talk to each other. You don't need to worry about any kind of crazy networking stuff. And basically what all this translates to is you can have your database, backend, and frontend all up and running just using one command on command line. And that's pretty sweet. So that's what we're going to cover today. So how does Docker work? It is composed of several parts. When you install Docker Desktop, what it actually does is it creates a virtual machine on your computer, because Docker only runs in Linux. And it runs a Linux virtual machine. And then Docker runs inside there. And it forms a bridge between your host system and that Linux virtual machine. That is the deepest theory we'll go into today. When you do Docker whatever commands on your terminal, it just talks to a Docker server in that virtual machine, okay? Now, that server manages two key things. One is images. Two is containers, okay? So, cool. There's your client, which is your CLI, your server, the daemon, which has your images and containers, and then there's also a Docker registry. This is where if someone has already made some environment, some Docker environment that you want to use, the registry is like a collection, a repository of different Docker images that you can just say, hey, I want a MySQL database. Thanks, done. No additional setup required, okay? These are pre-built images. So what exactly is an image? Well, there's a whole bunch of different pieces. An image, you can think of it like an environment template. The image is the part that you share with other people. The name for image comes from like old disk images, like CD-ROM. You would like burn an image onto it, and that would be your software. That's why we call it an image. And then containers are when you take this image, this template for an environment, and you actually create an environment, and you run that environment. That is a container. Okay, so you can think of an image like a blueprint, and then a container like the actual building made from that blueprint. And you can make a whole bunch of buildings from the same blueprint. Okay. I mentioned earlier registry. That's where you can get images. So if there's like a Python image or a MySQL image or like a, I don't know, some other image like a message queue image, Redis or whatever, you can just pull those. You don't have to configure it yourself. You don't have to write your own Docker file. You don't have to create your own Docker image. You can just grab it up from online. Next is the Docker file. A Docker file is a text file which creates a Docker environment that can be used to build an image. Okay? This is usually what you put in source control, your Docker file. And it defines what software is installed, what files are on the file system, and what command to run when the container starts. So for example, if you're running a backend API service like Fast API or something, I'm just using an example from my personal experience, you can get the Python image, then you can install the Fast API dependency, then you can configure any environment variables, and then you can say when the container starts, run the Fast API server. You're done. Now if you build an image from that Docker file, or if anyone else builds the image from the Docker file, they'll have the same exact environment. And you don't have to worry about, well, it works on my computer but not yours. You don't need to worry about that anymore. Okay? That's the main selling point of this. And Docker Compose.yaml, YML, basically allows you to define multiple Docker images. So let's say you have your Docker file for your application. It builds your own environment. Then you can use Docker Compose to say, hey, build my environment and set up all these other dependencies I might have. For example, connecting to a database or connecting to some other web server or something like that. Okay? Oh, we're actually doing really good on time. Wow, okay. Then we'll have some time to mess around and do some questions then. This is longer than the other one, so I was really worried. So we're going to go through and create a Docker image ourselves right now. I have just a trash little repository from a previous workshop, and I'm just going to use that as my workspace. We're going to create a Docker file, okay? And it has to be called, well, it doesn't have to be, but by tradition, it's called Docker file, okay? We're going to basically fill in the content like you have here on the right side of this slide. This is a very, very basic, not really useful, but still functional example. We're going to create a tiny little Python script that just prints hello world. And then we're going to, this Docker file here takes that Python script, adds it into the Docker image, and then that way if someone else uses this image, it has that hello world program built into it. And then we can build an image from this Docker file. We can, see our images. We can see that the image was built, and then we will run a container from that image. Okay, so we're going to do that interactively now. So, okay, so here I have some kind of tiny little repository. Okay, there's nothing really in here, so I'm going to go ahead and create a Docker file. Now, if you're using Visual Studio Code, when you create a Docker file for the first time, it will prompt you to say, hey, I know that's a Docker file. Do you want to install the Docker extension? And you probably want to say yes. It just makes your life easier, and then you can manage it from VS Code. But I'm an old man, and I don't like using UI stuff, so most of what I'm going to show you is on the command line. However, once you have the plugin installed, you can just manage your stuff here. But it's a bit of a mess, and I don't understand it because I like command line. I don't like pictures. Anyway, so you create your Docker file, and this is the traditional name. If you don't use the traditional name, you have to do a bunch of extra configuration. Don't do that to yourself. Just call it Docker file. Capital D, Docker file, no space, not a capital F. GG easy. Okay? And then, we have time, so I'll explain more as I go through it. When you start a Docker file, you usually choose a base image. Now, you're not defining a whole operating system from scratch. Theoretically, you can do that. You do not want to do that. There's no reason to do that. You want to find an image from Docker Hub, which is a website that's a Docker registry, I'll show it in a second, that has an image close to whatever you already want, or that has an image close to what you want, okay? So I'm building a Python application, so I want a Python image. So what I do is I go to my browser and I say Python Docker Hub. And then what do you know? There's an official Python image. And this is Docker Hub. This is the main registry supported by the Docker Foundation. There are other registries out there, but this is the main one currently. And there's all these different tags. These tags are different versions of the image, different versions of the environment. So for example, this one has Python 3.13.0 It's a release candidate, versus this one has 3.12.0. Now Bullseye is a version of Debian. It's an OS version. Alpine is a minimal Linux OS intended for tiny, tiny, tiny images. You'll want to, so the Bullseye images tend to have more software, more of what you would expect. The Alpine images tend to be very, very tiny, but don't have a whole lot of tooling built into them. And you have to go learn Alpine a little bit. So for our purposes, I'll be doing Alpine because I want my build to go fast. In practice, you may want to use one of the bigger Linux versions like Bookworm or Bullseye or whatever. If you don't know what Bookworm and Bullseye and all that kind of stuff are, just search Linux Bullseye, Linux Bookworm. They're different versions of Debian, one of the Linux distributions. Anyway, tangent, back to the main point. So I found an image on here that works for me. I want Alpine because I want a tiny image and I want Python 3.12. So what I said was I should learn how to type. That's what I said. Beej, you should learn how to type. So from is saying, hey, go grab this image from Docker Hub and use that as the base image. We're going to build on top of that. Okay, so I'm building on top of the Python 3.12.0 Alpine image. And then, once we've done that, I want to add a file from my computer to that Docker environment. So I'm going to add this main.py file to the current directory on the image. So it's source on the host machine and then destination in the Docker image. Now, I don't have a main.py. I'm going to add it in a second. Ideally, you want it to be files you want. Now, let's say that you have a fully fledged project. Maybe it's inside a source folder. You could just do add./source/star, and that would add everything there. Now, each different type of Docker image has different conventions about what the default folder is, what the workspace directory is, all this kind of stuff. You want to look through the Docker Hub page on whatever image it is that you decide to use, okay? But in my case, I know that I just want to add one file, so I'm just going to do that. So I'm adding the main.py to the current directory inside the image, and then I want to say when this image starts running, go ahead and run the command python and pass it the argument, which is my file that I want to run. And just to be abundantly clear, the reason that I do the add before the command is in the Docker image is a completely separate file system. It's like a completely separate computer. It's a clean, pristine Linux installation with Python installed. That's all it is. So I have to add my project files into the image. That's why we do the add step. If you don't do that and you do command, you're going to get an error like main.py not found, okay? So now that I have this, I'm going to just make a tiny little main.py. And I'm just going to say print hello world. Not world, world. There we go. Tiny Python program. It's beautiful. What? Yeah, I want to save. Okay, so I have a tiny little Python program, and then I have my Docker file here. Now, fun part. To do this, I don't actually need Python on my system, because Python is installed in the container. So if you have someone who's kind of more a junior person on their team, on your team, and you don't want to walk them through installing Python and all that stuff, just get the Python Docker container, run it in interactive mode. You can actually work on a project from inside a Docker container in Visual Studio Code, and that way you don't have to walk them through installing Python on their system. But that's maybe a little more advanced. Anyway, back to the project. So I'm taking full advantage of the extra time I have. So now, so I have my Docker file. My Docker file is complete. I can say docker build, and then you say dot. Dot means the current directory. Why do I need to tell it to build the current directory? I'm sorry that this is so tiny. Let me make this bigger. Oh God, maybe that was a mistake. Yeah, it's fine. Anyway, docker build the current directory. Why do I say the current directory? When you're building an environment, you're building kind of a context, right? So the context is the current folder. by default, Docker will look for a file called Docker file in whatever directory you specify to build the Docker image. So that's why we call it Docker file, okay? And then I want to give it a tag. Basically, I want to name the image because by default, Docker images don't have a name, they just have a hash. If I do -t to specify a tag, that will name the image. So I'm going to call it Docker demo, okay? You can call it the name of your project or whatever. So I'm going to do this, and what's going to happen is Docker is going to read my Docker file, and it's going to go through each step. The first step is from, so it's going to go pull that Python image from Docker Hub, download it, and set up the base image. Then the next step is going to add the file from my project directory into the new Docker image, and then it's going to configure that, hey, when you run this image as a container, run that command. That was fast. So if you run this on your computer, it's going to go a little bit more slowly because you have to download the Python image from Docker Hub. I did this last night, so I already had the Python image on my machine. That's why it was instantaneous. But you'll see it like download a whole bunch of stuff. You'll see like, loading bars and all that kind of stuff. Anyway, so now I built my Docker image. So if I do docker image ls, oh, I should have cleaned up after last night. Anyway, you can see my Docker demo image here. Okay, so that's the image that we just built. You can see it was built 26 seconds ago. And it's tiny because it's Alpine, so it's only 50 megs. Okay? So now, let's try running this container. Again, this container has this main.py, and it will run that main.py on start, unless I specify otherwise. So what we can do is we can say docker run. Now, just because I try to keep things clean, well, generally, you wouldn't know it from my image list. But if you do docker run and then --rm, that will remove the container after it stops. Normally, when a container ends, it just sits there in a stopped state, taking up space on your disk. If you do the --rm, it'll automatically remove it. You can also remove it after the fact, but this is a little cleaner. And then I want to say which image I want to run. So I want to run a container from the Docker demo image, and I want to remove it once it's finished. So I do this. And it ran. It stood up the environment, and it ran this Python command to python main.py, and all that did was print hello world. Does that make sense? Cool. I've taken full advantage of all this extra time. So now, so that's an example of how to create a Docker file. Now, on your project, you'll probably have something more complex. You'll want to add all of your source files. You'll want to maybe configure some environment variables for like ports or server to host or host IP to bind to, or database configurations and these kinds of things. You can do all that in a Docker file. I do recommend looking up the Docker file reference. It's actually very clear and easy to read. So going forward into Docker Compose. So cool, you have a Docker container for your application now, but maybe your application needs a database to work. How do we do that? Well, we can create a dockercompose.yaml file, which allows us to define multiple containers, and these containers are defined as services. Why is it called services instead of containers? Because let's say that I want to run a web server, but I don't want to run just one copy of the web server. I want to run 10 copies of the web server. No problem. You can just set the number of replicas to 10, and it'll make 10 containers as one web service. So you can have 10 copies of an environment. So let's go ahead and make a Docker Compose. Oh, actually, I should probably show you the slides that I'm talking about. Okay, come on, Beej, get your stuff together, my dude. Okay, there we go. Oh no, okay. So yeah, you want to create your dockercompose.yaml, and you want to specify the version because the specification of the file changes over time, so they want you to include the version. Then you want to specify each service. Services is fixed. These other ones like server, DB, adminer, those are arbitrary. Those are what you want to name your services, okay? Following that, you can either build an image, like I'm doing under the server service, or you can pull an existing image from Docker Hub. So for DB, for example, you see that image key. I'm specifying, hey, just give me the MySQL image from Docker Hub. And so it'll just pull that and use that for that service. But then for the server service, I'm going ahead and building a new Docker image from my current directory and then using that to create the containers. And then adminer is just a UI for databases. So we're just pulling that image. Now, you'll notice this environment bit here that allows us to set environment variables. The MySQL image specifically allows you to set various environment variables to set user passwords and usernames and all this kind of stuff to help you get your database up and running immediately without having to do additional configuration after the database has started. It just does this on start. And also, Docker Compose allows you to specify what ports to use, because in Docker, it's an isolated environment, right? It has its own network that's private. So if you have a web server running in Docker, let's say on port 80 or port 8000 or whatever, by default, you will not be able to access that from outside of the container. You have to tell Docker, hey, expose this port on my actual notebook, okay? So that's why we have this ports directive. So what we're going to do here is we're going to run our service here, and we're going to run a MySQL database and run adminer to see the MySQL database. So let's try it. I probably should have prepared this beforehand, but let's see how fast I can type. And I'm typing blind. I can't actually see what I'm typing, so let's see how this goes. Let's see how accurate I'm going to be. Oh, no. Oh, well, I tried. Whoa. Beach, get your stuff together, dude. Okay, there we go. Weird, I thought that it auto-indented. Okay, anyway. Why did I set that? Okay, anyway, I'll fix the slides later. All right, oh, nope, almost. There we go. Okay, so basically this is almost the same as what was in the presentation. So now that we have our Docker Compose set up, this defines our environment of multiple containers. You can just do docker-compose up, and then I want it to actually build my server image. So I'm going to explicitly tell it, hey, build the image. Why? Because if I don't do that, if an image already exists, it's just going to use that. But if you made code changes, you want it to rebuild the image and copy the new changes in. So it's a good habit to include --build. Otherwise, you're going to be like, I changed it. Why doesn't my Docker Compose show the change? Well, because you didn't rebuild the image. Okay, so we're just going to rebuild the image. So now, there we go. The database takes a little bit of time to set up because it is a database. It's a big, giant thing. And there we go. Now it's up and running. The first run, it has to do a couple of restarts. So now, Docker Compose, you'll see like it shows all this output. You'll see this colored text. This is, this is my project name, okay, which is just the folder name. And then it is the service name and then the number of the service. Because like I said before, you can have multiple containers for a single service. So if we scroll up, hopefully my history goes far enough, you can also see the other containers. So you can see the adminer container started, and you can see that our server container started and ran that hello world code like it did before. Okay, so there should be no surprises there. So now, if I pop over to my browser and I go to localhost 8080, which is the adminer UI, there we go. This is that adminer application running from Docker container. And then I can say, I also have configured here, I have the MySQL container defined as the service DB. Now the cool part is Docker Compose creates an internal DNS entry, an internal domain name for that service. So rather than figure out what IP address the container's at and all that sort of stuff, I can just say DB, and Docker will be like, I know which container this is. I'll just send you there. And then I set the root password to example. So we're going to do MySQL, the server name is DB, the username is root, and the password is example. I don't have a database, but I can log in. And there we go. I'm logged into that MySQL database through that adminer container. Okay, so this can be useful if you're building a backend application to set up a database and set up an interface for that database for you to inspect it without having to install any additional stuff. You can just do it all via Docker. Or if you're a front-end engineer and then you have back-end people on your team and maybe they've Dockerized their stuff, you can just set it up to run the API and the database on your machine, and then you can test your front end against a local copy. Okay? Does that all sound good? Cool. So, that's basically what we had planned for today. Again, it was very short, but we covered why use Docker. We want consistent, shareable environments, and we use Docker Compose so that we can configure multiple services to work together. We covered a bit how Docker works. You have your client, you have your server, which has your container and images, which has your containers and images, and then you have your registry, which you can use to grab additional things. We went through and created a Docker image from a Docker file, and then we set up multiple containers using Docker Compose. We have 5 minutes left, so any questions? Yeah. Right. So for the benefit of online and the recording, the question was, when would you use GitHub to put your code and Docker Hub to put your images? Like, how would you do this? So Docker Hub, you're only going to use if you want people to just download and run your software in Docker. Now, usually you don't want to do that, or usually you don't have a need to do that, unless you are actively publishing software for other people to use. So if you're creating an open source project, like let's say you're creating an education portal, and you want other people to be able to download and use your education portal without having to build from source, they can just download a Docker image and run your portal. That's a good case for using Docker Hub. You can publish your image to Docker Hub, and then other people can go download it. But let's say that you want your code to be open source, but it's not meant to just be run by other people randomly. In that case, you would use GitHub, but not Docker Hub. Does that make sense? Cool. Yeah. Docker Hub is more for complete applications that you want people to be able to just download and run in Docker without having to do any source stuff. Cool. For purposes of the hackathon, you'll probably only pull stuff from the Docker registry. It's not likely, unless you're specifically building software for other software people, that's really the only case you'd use Docker Hub, beyond just pulling. Any other questions? Yeah. Is Docker open source? Yes. Docker is written in Go, and I love it. Yep. So the Docker Foundation has its own organization. There is, if we look in repositories here, where is it? Yeah. It's somewhere in here. Docker Pi, BuildX. There's a lot. I don't remember, but it's somewhere on here. It's wonderful. It's written in Golang. I miss writing Go, but yeah. Any other questions? But there were some changes that Docker made around some of the licensing for Docker Desktop and for Docker Hub. But for the purposes of this hackathon, you don't need to worry about that stuff. Other questions? The reason I brought that up is because my company was previously using Docker Desktop, and then because they changed licensing, you have to pay now for Docker Desktop. We're like, let's all use Rancher instead, because we are cheap. So. So the question was, what are the alternatives to Docker? Is Rancher something you could use? So Docker has kind of genericized into, there's like Dockerd and then there's like Containerd. Containerd is kind of the generic thing that basically accomplishes the same goal and is fully compatible with Docker. I think Docker actually uses Containerd under the hood now. But in any case, it's more like Docker Desktop. That's the point that people want to switch, which is just basically how to run a Docker server on your like end user machine, rather than running Docker on like a full Linux server or something. There was There was an alternative back in the early days. There's like CoreOS and all this kind of other stuff, but it never really picked up. It's not very popular. Docker is pretty much the way to run containers these days. That said, for end users like us engineers, Rancher is a good alternative if you don't want to use Docker Desktop. It has its own interface to Containerd, or you can use the Docker interface to Containerd, which I believe is called Moby, hence the whale. But yeah, does that answer your question? Cool. Any other questions? All good. We're right on time. Well, thank you very much for your time, everyone. If you have general questions, please ask them in the workshop chat, because we're not allowed to give help to any one group that we don't give to other people. So any other questions you have, please share them publicly. Thanks, and bye-bye.